Okay, I'm going to go through a little answer key to that pH simulation in case you wanted to check your work. So let's start with these review questions before we start the simulation. So acids tend to produce H plus slash H3O plus. I want you to think of those as the same thing. That's called the hydronium ion in water, and they have a low pH. Bases tend to produce OH minus or the hydroxide ion in water and have a high pH. A strong acid or base tends to dissociate more in water. That means splits apart. Which are the strong acids? So I'd like you to memorize these / write them down on a piece of paper. They are HCl, HBr, HI, HNO3, HClO4, and H2SO4. You might find some others if you do a Google search for them, or if you look in a different textbook, but I'm just going to use the 6 that were mentioned in our book. So if you refer to that, you'll always be okay. Which are the strong bases that would dissociate completely? LiOH, NaOH, KOH, SrOH2, CaOH2, and BaOH2. Okay, now let's move on to the simulation. So we have our macro here. So what we see is our little solution here. We got this magic little like pH thingy here that we can shoot in there. And we got a little drain and some water. So let's start by checking out the pH of some of these substances. So we got drain cleaner here, pH 13. We got some hand soap, pH 10. Blood, okay, we got some blood, 7.4, blood slightly basic. Awesome, we got spit. That's what I was hoping to measure the pH of. Spit, pH 7.4. We have water, pH of 7.00. Moving down, we got some coffee, 5, some soda pop, 2.5. Oh, nice, vomit. Like, great, we got spit and vomit. So the vomit, pH of 2, very acidic, maybe due to that HCl that's being pumped out from our stomach. And then at the bottom here, we have some battery acid, pH of 1. So what is the range for the pH scale? It looks like over here it's going from 0 to 14. Which substance has the lowest pH? That battery acid. Which substance has the greatest pH? The most basic would be that drain cleaner. And then what happens to the pH when you add water? Well, if you start with something with a high pH, it looks like when you add water, the pH goes down. I think based on right now, we'd say pH tends to go down when you add water, but let's see what happens when we add water to an acid. Okay, now it goes up. So maybe the trend is that when you add water to an acid or base, the pH approaches 7. So pH will approach 7. Now something interesting, if you add water to an acid or a base, the pH can never really cross 7 because water is this thing we say it's amphoteric or amphoprotic. It kind of can act as an acid or a base, and it's got that perfect neutral pH. Okay, now let's click on the micro down here. Okay, so now it's actually telling us the amounts of these H3O plus hydronium ions and the amount of OH minus in these different solutions, with this little fancy pH meter here. So what we see with water is that the concentration of H3O plus is exactly equal to the concentration of OH minus. So when substances have a pH, I'm kind of doing question 3 first because the water was up here. So when substances have a pH of 7, the H plus is equal to the concentration of OH minus. Now let's check question 1 here. When substances have a pH greater than 7, like drain cleaner, whoa, check this out. It looks like the concentration of OH minus for this one is way greater than the concentration of H3O plus. Maybe something that is maybe a little less basic, like spit, just slightly more. But I guess the trend is that when substances have a pH greater than 7, OH minus is going to be greater than H plus. Now let's check out the acid. So we might have guessed it by now, but when we have an acid, the concentration of H plus or H3O plus will be greater than the concentration of OH minus. So for question 2, when substances have a pH less than 7, the H plus will be greater than the concentration of OH minus. So to kind of summarize this with questions 4 and 5, I guess I would describe acids as tending to have a high concentration of H plus and a low concentration of OH minus. And I would describe bases as tending to have a low concentration of H plus and a high concentration of OH minus.